disciplinary character. So I will present a joint work with my co-authors Tiziano De Angelis and Olivier David Zerbib. And since I don't have much time, I will move directly to the motivation of my talk. And sorry if I will not be able to cite almost any relevant literature due to time constraints. So the motivation of our work is to understand how green investors can actually encourage companies to reduce the greenhouse gas emissions. So how can sustainable investing impact the real economy? Because if we look at the data, we see that there is some correlation. For example, in this graph, we see that the amount of funds that is managed using sustainable investing practices has grown over the last few years. And at the same time, the average carbon intensity of US companies, for example, decreased. So there is clearly a correlation, but is there a cause and effect relationship? And we are developing a model to understand this relationship. There are several channels in which green investors can impact the decarbonization of the real economy. They can, for example, invest into small, impactful companies that have difficulties in accessing funds in order to enable them to grow. They can also engage with the management of the companies, for example, by voting in general assemblies of shareholders, so shareholder engagement. But we are, in this paper, in particular, interested in the impact channel through the cost of capital. In other words, investors can redirect funding flows away from brown assets and to the green ones in order to put pressure on share prices of brown companies, increase the cost of capital, decrease the cost of capital for green companies, and in this way, create an incentive for brown companies to decarbonize themselves and make life easier for green companies, make it easier for them to grow. All right, so here is the main idea of our model. We build an equilibrium model with a bunch of companies and two investors. So these are the companies. Sorry. And there are two types of investors in the model, the regular investors and the green investors. The investors will choose dynamically their asset allocations based on the expected returns and the expected climate impacts also of companies. And the companies choose their emission strategies, so carbon footprints, so emission schedules, in order to maximize the share prices and depending also on what other companies do. So in other words, it's a dynamic. So mathematically, there will not be too much math in my slides because I don't have time to present the model in detail. But here are the main ideas. It's a dynamic equilibrium model with two types of agents, or even three types of agents. There are green and brown investors on one side, and there are companies on the other side. Companies will pay a terminal dividend, and the dividend has a market risk component. So this integral with respect to Brownian motion, market risk. And there is also a climate impact component. So this is the climate impact component. And as you see, it depends on the process psi, which corresponds to the emissions of the company. And we apply a function theta to this company emission psi. And this will be the climate impact component of the dividend paid by the company. Typically, theta is a decreasing function. So the more the company emits, the stronger will be the negative climate impacts on these companies' dividends. And a key point in the model is that these climate risks and impacts, they are assessed differently by different investors because the different classes of investors, the brown and green, they have different views about these future climate impacts. So basically, they would have a different probability. And what is a Brownian motion for one investor, for green investors, will be a Brownian motion with drift for the brown investors. And so this enables us to change this impact function. And the investors on the other side are risk-averse utility maximizers. They determine the investment strategies. And through the investment strategies using the classical equilibrium dynamics, the share prices are determined through market clearing. So from the point of view of investors, it's a classical equilibrium model, but there's an extra ingredient because the companies, they also optimize something by choosing the emission schedules. They maximize their share prices, and so maximize share prices and minimize abatement costs. And we look for optimal strategies of the companies, optimal emission strategies, as a Nash equilibrium. So there is a two-layer equilibrium in the model: the financial market equilibrium to determine the share prices, and the Nash equilibrium to determine companies' emission strategies. All right. And so now I will simply, since as I said, I don't have time to go into details of the model, I will try simply to give ideas of the main contributions and the results of our study. So first of all, it's a mechanism of impact investing, because in our model, we have two classes of investors with heterogeneous beliefs. And so green investors, since they have different views about future climate impact of companies, in equilibrium, this will lead to different impact on share prices of companies if there are more green investors. So the fact that there are green investors pushes the companies to reduce their emissions. In particular, we have a tractable formula for equilibrium emissions of every company. So here we have the ith company, depending on the model parameters, such as the marginal abatement costs of the company in the numerator. And in the denominator, we have the proportion of green investors alpha and the sensitivity of investors to climate risk. So this parameter kappa determines the stringency of the investors and the sensitivity of climate risk. And so we have this beta C and beta 2 deterministic function of time. So this gives us these curves that we can now plot, which tell us what the optimal emissions schedule of every company will be, depending on time. And in particular, we see that if there is a higher proportion of green investors, or if these green investors have a higher sensitivity to climate externalities, to climate impacts, then this will also reduce the equilibrium emission in the real economy. So, for example, with some simple calibrations, we can compute that when 50% instead of 25% of assets are managed by green investors, the company will reduce its emissions by 3% a year instead of 1% a year. And here, there is also an important point. The actual emission reduction rates that we find, they're actually quite low. So this means that this impact channel through the cost of capital, it exists. So there is a cause and effect relationship, but it is not very strong. And other impact channels should not be neglected and are also necessary to achieve good decarbonization rates. Then we look at the impact of anticipation of climate-related regulations and technological innovations, which are also part of the model. And we show that they also reduce the emissions of companies. Next, an important point in the paper is the impact of uncertainty about future climate risks. So we show that if the future climate risks and impacts are uncertain, and I will explain in just a second how this uncertainty is introduced in the model, then the impact of this uncertainty is negative. So the impact of green investors is less strong if the future impacts of if the future climate risks and impacts are uncertain. More precisely, here is what happens in the model. To introduce uncertainty, we modify the model a little bit. We suppose that in the dividend of every company, instead of a deterministic component depending on the emissions of this company, there is a stochastic component due to climate risks. So instead of DT here in the previous version of the model, we have a Poisson process. So the same climate impacts, which depend on the company's emissions, now they appear at random future dates. And these dates are determined by this Poisson process with intensity lambda. So lambda is the parameter which determines actually how frequently these impacts materialize and how large they are. If lambda is small, this means that the climate impacts happen only rarely, but they are very large in size. And if lambda is large, then we have small frequent impacts. So for small lambda, the climate uncertainty is large. And then we have a slightly different formula, which also gives us the equilibrium emissions of every company, depending also on this uncertainty parameter lambda. And so we find that the higher the uncertainty, the less will be the emission reduction. For example, if this lambda, 1 over lambda is, for example, equal to 5, so this means that information about climate risks only becomes available like every 5 years, then this will reduce by 2% the rate of emission reductions for a company. Uncertainty is a key point, very important point in the model. And finally, in the last part of the paper, we provide a little bit of empirical evidence. So we do some data analysis. In particular, we use the holdings of green funds, so funds that are declared as green. We see how much assets they hold, as a proxy for the proportion of green investors. And we look at the impact of the fraction of green investors. And we also look at the impact, using also some proxy, of uncertainty about future climate risks on the carbon intensity of companies. And so we find that if, for example, the fraction of assets, by using these calibrated parameters, if the fraction of assets managed by green investors doubles, we find that the carbon intensity of companies drops by 4.9% over 1 year. Once again, we need a lot of green investors in order to achieve reasonably small emission reductions. And when uncertainty about climate risk doubles, the carbon intensity of companies increases by almost 7% over 1 year. So uncertainty has a strong negative impact. And so to close my short talk, to the main takeaways are as follows. The impact is stronger when the wealth share of green investors is larger. So this, of course, emphasizes the need to support the development of green finance. The impact also increases with the environmental stringency of green investors, and this advocates the development of various frameworks, taxonomies, and labels, which allows the green investors to discriminate clearly between green and brown companies and be more selective in the asset allocation to avoid greenwashing as well. The impact grows with anticipation of future climate regulations and innovations, and this is an encouragement to facilitate the development of regulations and also developing innovative technology of emission reduction. And the impact decreases with uncertainty about future environmental risk, which of course highlights the need for more climate transparency and better climate disclosures and better information about future environmental risks. And at this point, I think I almost run out of my time, so I will close end my talk here, and thank you for your attention.